All right, so volume of cylinders. So first of all, we have to know what a cylinder is, okay? So there's a picture of one here, and there's one on your formula sheet as well. Can we think of some instances or some examples of cylinders like that you could see in a word problem, because it's things that are like in real life? Yeah, soda can, any type of can would be a great cylinder question. What else? A lot of you guys, like your water bottles, it might not be a perfect cylinder, but it's pretty close. You mentioned soda can. What else? Glue stick. Perfect. I didn't even think of that last block. Okay. What else? Water bottle? Yeah, like a water bottle could be. Paper towel. Yes, paper towel rolls. Perfect. All right. So a cylinder is a solid that has two parallel, getting into our vocab from our unit with quadrilaterals a little bit there with parallel, but it's a solid that has two parallel congruent circular bases, okay? So if you look at the cylinder, the top and the bottom are both circles. That's what it's talking about with two parallel congruent circular bases. It's just kind of like a textbooky definition there for you. Now the side of the cylinder, we're not going to pay attention to it as much with volume, but it will make a difference with surface area. The side of the cylinder is called the lateral surface. So like I said, we will do more with that next week, but there is the vocabulary for you when you see it later. Now there's two different parts of the cylinder that we need to know in order to like plug values into our formula. So what's one of the parts of the cylinder? And here's the kind of the picture from your formula sheet down here. What's one of the parts of the circle that we need to know? Look at like what your letters are on here. You need to know the radius. That's our first blank here. So the radius is the distance that's halfway across the circle, okay? And again, on your formula sheet, it does label it for you. Like there is a dotted line that goes halfway across the circle, and there's an R there. So if you forget what the radius is, look at the picture. What is the other part of the cylinder that we're going to need to know? You don't need to know the diameter for this formula, but you need to know what diameter is, because sometimes we have to do like an extra step calculating. Height. The height, exactly. So the H here stands for height. And again, it's kind of like a wordy definition here, but we'll talk about what that means. It says the perpendicular distance between the two bases. Okay, that sounds like a lot. But what that means is it's basically the distance between the two circles. The reason I have it worded that way is because it's not always what's going up and down. Because some of these like cylinders in our examples here, they're laying sideways. So the height is not always what's going up and down. It's just the distance between the two ends, even if your cylinder is turned sideways, okay? So the formula that we have that we're going to use, there's actually two formulas on our formula sheet. The first one that's listed is that volume is equal to pi r squared h. Now this first part of the formula should look familiar from last year and from our focus question, because we did an example with this. Where have you seen pi r squared? Huh? Our focus question, but what was our focus question asking us to do? All right, so what was our focus question asking us to do? To find the area of the circle. So this first part of our volume formula is the formula for area of a circle. The second formula that's listed on the formula sheet is that volume is equal to base times the height. So the base, that is basically whatever the area of the circle is. So you take the area of the circle, if they happen to give it to you, that's the base, and you can just multiply it by the height. A lot of the examples we're going to be doing, they're not going to give you the base, so you have to just use this first formula. And pi is in this formula. We talked about this as well with our focus. What is kind of the approximated, like the rounded value for pi that we use? 3.14, good. So most of the examples or what we use in our for our homework, for our the IXL we're going to do, the classwork we're going to do, it will tell you to use 3.14. It actually makes your life easier because you don't usually have to worry about rounding as much. Sometimes you'll still have to round, but you're not going to get such crazy decimals. All right, so 4 examples here, starting out with the picture. So again, you do have to know how to interpret the picture, know what the different parts of the cylinder are. For each of these, we're going to solve for the volume of the cylinder. So yesterday I said you need to know, in order to find what formula you're using on your formula sheet, you need to know the shape and what you're solving for. So the shape is the cylinder, and then what we're solving for is volume. So in our first example, we're going to write the formula first. So volume is equal to pi r squared h, and please write all of these steps in your notes as well. When you're doing this on your papers and practicing this, I know you're putting a lot of it in your calculator, but I need you to write it on your paper in your notes so that you know like where these numbers ultimately came from, okay, when you're looking back at your notes. What are we going to substitute in for pi? Yep, we're just going to go ahead and put the 3.14. And so that we don't get mixed up with decimals and time symbols, I'm going to use parentheses basically here on out to show multiplication. So I'm going to put the 3.14 in parentheses. I'm going to multiply it by the radius squared. What is my radius for this cylinder? Yeah, it's the 3 right here. So I'll label it on the cylinder, and I'm taking that 3 and then I'm squaring it, and then I'm multiplying it by the height. What is the height of this cylinder? The 4, good. So then the 4 goes in parentheses there. Now, the great thing about when we're doing like our notes, or you're doing like an entire worksheet that is practicing the same skill, you really can just put your formula in one time, and then you can just change your radius and your height. So using that like replacement value option to kind of save you some time if it's the same thing you're doing over and over again. I'm going to go ahead and type in my formula, but instead of using pi, I'm going to type in 3.14. So there is that pi button we talked about, but for our purposes, we're going to use 3.14 times my radius squared times my height. Then you can just tell Desmos that in this case your radius is 3 and that your height is 4, and then I have my answer. So I have 113, my volume is equal to 113.04. Now, did they give us our units in this example? Did they tell us inches or meters or anything? No, so we're just going to write out the word units. And then what exponent do we use for volume? The 3, so cubed, okay? You can't just put 113.04 cubed, because that would mean you're multiplying that number times itself 3 times, and that's not what we want. You do have to write out whatever the units are, or write the word units, and then cube the units. Second one, same thing. We're going to start by writing the formula. So volume is equal to pi r squared h. We know that we are substituting in 3.14 for pi. What is the radius of this cylinder? 2. So that's my radius. I'm going to substitute it in here. That gets squared. And then what's my height? Good. So here's my height. That's 9. All I'm going to have to do in my calculator is just change what the radius and the height are, because again, it's a bunch of questions that are all asking you to solve for the volume of a cylinder. Change that to 9, and I get 113.04 And again, this did not give me units, so I would write out the word units cubed. What do you notice about the answers for both questions 1 and 2? They are the same. Okay, so sometimes you just have to kind of think about what the volume means. It isn't how much space takes or like fills the inside of that cylinder. So they happen to work out in this case to be the same. The first one is definitely shorter, but it's like wider. The second one is skinnier, but it's taller. So you can have cylinders that look very different that could have the same volume. In this case, numbers 1 and 2 do have the same volume. All right, moving on to 3. So we'll start out with our formula. Volume is equal to pi r squared h. Pi, we're going to substitute 3.14. What is the radius? Good. This one is laying sideways, but your radius is always halfway across your circle. So your radius is 4. So that's what's going to get substituted in the formula for my radius. And then what is my height? Good. Even though this looks like it's going like left to right, the height is the distance between the circles, the distance between the two ends of your cylinder. So then I multiply times 15. I'm going to change my values of my radius and my height. So radius is 4, height is 15, and I get a volume of 753.6. What are my units in this case? They did give me units. Feet cubed. Good. All right, and then our last one before we get to those word problems. So start with your formula. Volume is equal to pi r squared h. Pi, we use 3.14. What is my radius?
4.
Ah. So this 8 is going all the way across the circle. What is that called if you're going all the way across? That is your diameter, okay? We do not use diameter in this formula, so we have to figure out what the radius is. If I'm given the diameter, how do I figure out the radius? What do I have to do to it? Divide it by what number? 2. Good. You're cutting it in half. So down below, I'm just going to write how we're getting what the radius is. It is the diameter divided by 2, which in this case, our diameter was 8. We divide that by 2, and so what is our radius? 4. Good. So when I substitute things into my formula, I'm going to use 4 squared rather than 8 squared. I'll get a very different number if I don't cut it in half first. And then my height is 16. Good. The values for this cylinder are actually quite similar to the last example. So my radius is still 4. I just have to change my height to 16. And so that is my new answer. I have 803.84. What are my units? So centimeters cubed. For the word problems, I'm going to kind of get rid of the calculator so that we can see the full word problem. And then some of you guys that do have your laptops up can help by giving me the answers once you have them typed in. Okay. All right, so our first word problem here. So example 5, a cylindrical paint can. Well, we're lucky enough here that they actually told us that this paint can is cylindrical. So I'm going to circle cylindrical. That tells us our shape. If it didn't say cylindrical, like we already talked about, cans are cylinders. So you could focus in on where it says paint can. That's also telling you it's a cylinder. So a cylindrical paint can has a diameter of 12 centimeters and a height of 16 centimeters. It asks, what is the volume of the paint can in cubic centimeters? What word tells me I'm solving for volume? Volume. If it didn't straight up give me that word, there is something else that would indicate volume. And it kind of has to do with our exponent. Cubic, yeah, because if we are cubing our centimeters or cubing whatever our units are, then that means we're solving for volume. So even if they didn't straight up say volume, if you are cubing your units, that's what you're solving for, okay? All right, so formula. Volume, I'm gonna zoom in a little bit because I do have to write kind of small to make this fit. So our volume is equal to pi r squared h. Make that focus a little bit better. Okay. I'm going to substitute in 3.14 for pi. Now, what is my radius? Yes. Okay. This right here, the 12, that's a diameter of 12. Okay. Diameter is not part of the formula. So to get our radius, we're going to take that diameter of 12, we're going to cut it in half, and that gives us 6, okay? So then we have 6 squared times, what is my height? 16, yeah. So those of you that already have your, or still have your calculators up, what do we get? 1,808.64. What are my units? Centimeters. And then what do I do after centimeters? Perfect. Okay. Look for the shape and then what you're solving for. Just be careful if they give you volume, or excuse me, if they give you diameter, you have to cut it in half to get radius to use for the formula. And then our last example, a powdered drink mix is stored in a cylindrical container. So again, cylindrical gives it away, the shape, that has a radius of 6 centimeters and a height of 14 centimeters. Which is closest to the maximum number of cubic centimeters the container will hold? So I'm going to underline that final question of what we're solving for. This does not say volume anywhere in it, but how do I know that I'm solving for volume? So both of those. Hold, we talked about with our rectangular prisms, and like we just talked about in the last example, cubic as well. So it's kind of reinforcing it, like you have two words there telling you that you are solving for volume, okay? So volume is equal to pi r squared h, and we're going to be substituting in our radius and our height. What is our radius? 6 centimeters. What's our height? 14. I'm just jotting these over to the side because that's what you would need to be putting into your calculator. In our work over to the side here, we're substituting 3.14 for pi. Our radius is 6. That gets squared. And then we multiply by our height of 14. And what is our volume? 1,582.56 centimeters cubed. Perfect.